Hello students, welcome. Previously, lesson 2 from 2 to 3, we were dealing with the structure of ionic compounds and also the physical properties of ionic substances or ionic compounds. So today, lesson 3, we want to go to the second type of bonding, which is covalent bonding or covalent bond. We are done with ionic bonding, and today we want to proceed to covalent bonds or covalent bonding. So what's covalent bond? We are saying this is a type of bond in which when atoms combine by sharing electrons, their respective nuclei attract the shared electron holding the atoms together. If you remember, we said ionic bonding exists when a metal reacts with a non-metal or when a metal combines with a non-metal, like sodium reacting with chlorine. Sodium is a metal and chlorine is non-metal. Sodium is positively charged cation, chlorine is a negatively charged anion. So the type of bond that will exist in between them is ionic bonding. So today we are going to do covalent bond, and covalent bond will exist when two nonmetals combine. Examples. So I told you use dots and cross diagrams to show bonding in the following compounds. So the way we have done even ionic bonding, you have to know first of all how to write the formula of the compound. So here we're having part A, hydrogen molecule. So hydrogen molecule is written H2. That means hydrogen molecule is made up of two atoms of hydrogen. So the two hydrogen are nonmetals. So when nonmetals combine, they form covalent bonding by sharing their electrons or by sharing electrons. So the first step, what we are doing is that we are drawing the atomic structure of hydrogen. Remember, hydrogen has only one electron, and this is for the other hydrogen. So we are giving cross and dot to differentiate the two hydrogen. Then we are going to have our arrow to direct or to point the product side, and that's where we are going to mark during the exam. So how are we going to do this? First of all, we are supposed to have the formula. The formula is H2. What does this mean? This means we are going to have the nucleus of the first hydrogen, and we are going to link with the other hydrogen, and this is its nucleus. So we ask ourselves, these are the two hydrogen. So this one I can give cross, this one dot. So I ask myself, what is the number of electron for this hydrogen? It is 1. This one is also 1. Electronic configuration of 1 and 1. So I ask myself, for this hydrogen to become stable, what does it need? It needs one electron to accept, or 1 electron to give. What about this hydrogen? The same. It requires 1 electron for it to attain stability. So what they do is that they share 1 electron. So that means this one will bring 1 dot, and this one will bring 1 cross. So that means this is where we have the shared pair of electrons or the shared paths. So when we do something like this, we are going to try to confirm whether everything is okay or not. So we're going to start with the first one. The first one, as you know, was having 1 cross. And if we check the outermost energy level of this one, it is having 1 cross, and it has accepted a dot the way you see in its outermost energy level. We go and confirm the second one again. The second one was having 1 dot. So when you check it is outermost energy level, it's having 1 dot. Then it has accepted 1 cross from the other hydrogen. So that means we said this hydrogen will bring 1 electron, this one will bring 1 electron, they are going to share. That is how covalent bonding occurs. So we go to part B, that's oxygen molecule. So the way we write oxygen molecule is O2. Oxygen molecule is made up of 2 atoms of oxygen. So how are we going to do the bonding? First of all, I'm supposed to have the first oxygen here, O, with electronic configuration of 2,6, because oxygen has an atomic number of 8. We can represent this oxygen cross. We go the other oxygen again, the same, with electronic configuration of 2,6, but we can give it a dot. Then let's just try to draw now the structure of oxygen molecule. First of all, I'm going to draw the nucleus of the first oxygen, and it is outermost energy level. That's the outermost energy level. So the first energy level, it doesn't matter. If you can draw, you can draw. If you can leave, it doesn't give any problem. Okay, we're going to link with the other oxygen, and the other oxygen, that is its nucleus. Okay, then we ask ourselves, for this oxygen to become stable, what does it require? It requires 2 electrons to be in. So those 2 electrons will be gained from this other oxygen, which is having dots. So that means we take 2 dots to the shared part, like that. So we go to the other oxygen again. This is the other oxygen. So for this oxygen to become stable, it can gain 2 electrons. So this 2 electron will gain from this oxygen which was having cross. So we will be seeing 2 crosses in the shared part, that part. So we are going to see now the outermost energy level of each oxygen. So we come to the first one. It was having 6 crosses initially, but how many do we have now? 1, 2 cross only. So we need 4 more crosses to complete its outermost energy level. So when you check the outermost energy level of the first oxygen, it's having 6 crosses, 1, 2, 3, 4, then 5, 6. Then it has gained 2 electrons from the other oxygen. We go to the second oxygen, this one here. It was having 6 dots initially, but now I see only 2 dots, 2. So it's remaining 4 more dots, 1, 2, then 3, 4. When we confirm, it's having 1, 2, 3, 4, 5, 6 dots as usual. Then it has gained 2 crosses from the other oxygen. So we have already done bonding in oxygen molecule using dots and cross diagrams. So we can represent this oxygen molecule in another way. That is, I can have this oxygen, it is chemical symbol, that's O. Then we take 1 dot with 1 cross will give us single covalent bonds. Then another dot and another cross, we are going to have another single bond. Then we are going to draw or to write the chemical symbol of the other oxygen. So in part C, we are having nitrogen molecule. So nitrogen molecule is composed of 2 nitrogen atoms. So we can do the same. We can start with the first nitrogen. Here, a nitrogen is number 7, so electronic configuration of 2, 5. So the other nitrogen the same, 2, 5, but we can give dot to differentiate the 2 nitrogen. So we draw the nucleus of the first nitrogen, and this is its outermost energy level. We will link with the other nitrogen, and this is its nucleus, like that. So what we are going to do is we say for this nitrogen to become stable, what does it require? It requires 3 electrons. So those 3 electrons will be gained from this nitrogen, which is dots. So we see 3 dots in the shared part, like that. Then we go to the other nitrogen. We said for this nitrogen to become stable, what does it require? It requires 3 electrons. So those 3 electrons will be accepted or will be gained from the other nitrogen, which was crossed. So we can see 3 crosses in the shared parts, like that. Then we see the outermost energy level, how it is. So check here, we are having 5 crosses in the first nitrogen. But if you see, it's having 3 crosses only, 1, 2, 3. So that means we need more 2 crosses, 1, 2, to complete the outermost energy level for that first nitrogen. If we confirm 1, 2, 3, 4, 5 crosses plus 3 dots will give 8. So check again the second nitrogen, it's having 5 dots. So when we check 1, 2, 3, it has only 3 dots in the pair, in the shared part. So it needs 2 more dots, like that. So when we confirm, it's having 1, 2, 3, 4, 5 dots plus the 3 crosses that it has gained from the other nitrogen. So this is how we are going to draw the nitrogen molecule. If you want to do it another way again, we can write N, then 1 dot with 1 cross, that's single bond. 1 dot with 1 cross, we are going to get another single bond. 1 dot with 1 cross, we are going to get another single bond. Then we are going to write the chemical symbol for that other nitrogen, which is N. So nitrogen bonding with another nitrogen forms triple bond, triple covalent bonds.